Welcome back. Today we're going to talk about derivatives of trigonometric functions. And trig functions are those things that you probably remember from either a trigonometry class or an algebra class. So like sine of x, cosine of x, tangent of x, and then of course there are the three others. And just so you know, trig, the root tri comes from triangle, and that's what the trig functions are all really about. So to do derivatives of trig functions, if you're kind of old school and into doing lots of long things, cool, you probably aren't somebody that's buying my videos. Then you could really just prove this and then get all the others from that. But that's not really what we're about. We're about little pieces of things that make your life easy so you can go and serve and play disc golf. So what I'm going to tell you is you're going to want to just quickly memorize, like over the week before your exam, the derivatives of these 6 trig functions. So the 6 functions are sine, cosine, tangent, cosecant, secant, and cotangent. And what I've written here is the prime mark. So this means the derivative of sine of x is cosine of x. The derivative of cosine of x is minus sine of x. So that's kind of funny, huh? They just flip, except this one has a negative sign. And then the 4 other derivatives are written here. And as you work on memorizing these, you'll probably notice the pattern, like this is a cosecant and a cotangent, this is a secant and a tangent, one is negative, one is positive. But if you're doing a lot of homework problems, you won't have to work that hard to memorize these. You could just put them on a little note card, and as you practice more and more, these will just fall out of your head in a positive way. But if you're not practicing a lot, just make sure you glance over them before an exam, because even if you know how to do all the other things in calculus, if you can't come up with these, you're not going to be able to finish your problem. Okay, so write these down some more, and then we're going to actually attack a problem and see if we can do it. So for our example, let's take this function, and this tells us we're going to have to use the quotient rule to find a derivative because, in fact, we have a quotient. We have secant x over 1 plus tangent of x. But to actually use the quotient rule, we're going to need to know how to get the derivative of secant x and the derivative of 1 plus tangent of x. So what I did is I just reminded us over here on the side of the board what we had, the 6 derivatives of the trig functions. I just grabbed the 2 that we're going to need so we can see where these are going to come in here. So to find h prime of x, we're going to use the quotient rule. And the quotient rule tells us take the derivative of the top function. So I'm going to just write out secant x with a prime next to it, and we'll take the derivative in the next step. Multiply that guy by the bottom function. And now we're going to subtract the derivative of the bottom function times the top function. And the quotient rule says divide everything by the bottom function squared. Okay. So if you're a little confused about where this came from, go back and watch the video on the quotient rule, but I'm going to assume that you're hanging with me just fine. And now let's actually take the derivative. So wherever I'm seeing the prime mark, I'm going to have to grab the derivative of that. So the derivative of secant x, this is going to help us remember. I'm going to rewrite that as secant x times tangent x. So that is this. Now that's multiplied times 1 plus tangent x minus the derivative of 1 is 0, so I won't even write that. The derivative of tangent x is secant squared x. And that's still times secant x. And the denominator is 1 plus tangent x quantity squared. And remember the hint I told you before, don't bother foiling this out. That's not going to make our life any easier. Okay, so we're actually kind of done as far as getting the derivative, but your teacher is going to want you to massage things and give a much more simplified answer. So looking at this, I see a secant x and a secant x over there, so I'm going to factor that out in the front. And then I'm going to go ahead and distribute this tangent of x into here, so tangent x plus tangent squared x. Minus 1 of the secants came out, so secant squared x like this. And then everything is divided by the 1 plus tangent x quantity squared. So this looks okay, but not super great yet. And depending on your professor's expectations, maybe you just want to leave it like this. But one thing that might be kind of impressive to them is if you can remember some trig identities and collapse things a little bit. So let me just show you how to do that because it might be useful for some other problems. But if you're completely overwhelmed by that, this would probably get you like 8 or 9 out of 10 points at this point. So not too bad. So the trig thing I want you to remember, you've probably learned that sine squared of x plus cosine squared of x equals 1. And that's really just the Pythagorean theorem. Now, I'm not seeing sines and cosines here, So I need to do a little bit of massaging. If I divide everything in this identity by cosine squared, and then if I rewrite what I really have, well, sine over cosine is tangent, so that's tangent squared x. Cosine squared over cosine squared is 1, and then 1 over cosine squared of x is really secant squared of x. So in this line, I have another identity that came from this first one, and I'm seeing tangent squareds and secant squareds, and I'm seeing tangent squareds and secant squareds over here too. So if I move this secant squared over here and the 1 over here, we might be in good shape. Let's see. I'm going to say tangent squared x minus secant squared x equals minus 1. Now, the reason that was helpful to me is look at this guy and then look at this guy here. So what that tells me is if I want to, if I feel motivated to reduce things, I can replace this tangent squared minus secant squared just with the number minus 1. So instead of writing that all out, I just put a minus 1 there. So I just went to the trouble to show you this because you'll have some problems where a little bit of massaging works in your favor. But again, if you're totally overwhelmed by that, you've gotten most of your points at this place. Okay, for this example, we have a function that's the sine of some junk. And anytime you're seeing junk, you're thinking to yourself, aha, chain rule. So we need to use the chain rule, but we're also going to have to remember the derivatives of trig functions because we're seeing this sign out here. Now, let me just write this for you. You have it on your note card, or if you're super speedy, you already have it memorized. But the derivative of sine of x is cosine of x. Now, this is going to help us, but it's not going to completely solve the problem because our original function is not sine of x, it's sine of junk. So we have to use the chain rule for that. So the way the derivative works for the chain rule is we go the derivative of the outside function, evaluated the inside function, times the derivative of the inside function. So the derivative of the outside function is sine, its derivative is going to be cosine, and we're going to do cosine of the junk, and then times the derivative of the junk. So don't write this on your exam or your homework, but I'm just putting this here so you see the pattern. What I really mean by that is cosine of this 4x squared plus 1, and then times the derivative of 4x squared plus 1, like this. Just to be clear, you certainly don't need to write this dot for multiplication, but this cosine with this set of parentheses next to it is not multiplication, this is composition. It's cosine of this function, and then this is multiplied by the derivative on the side. So I have cosine of the junk, and then over here I'm going to get an 8x and then plus 0, so I won't bother with the 0. And just to be sort of consistent with what people usually do in math, this is completely correct, but we would probably want to float that 8x in front just to follow convention. So this is the derivative of our original function. So we used the chain rule and we used the new trig derivatives that we've just learned. So I hope you guys have a great day, and we will see you for our next lecture, which will be about derivatives of exponential functions.